All right.
You
finished?
As soon as you said that.
All right. So I will try to get those masteries graded by tomorrow. For those of you playing at home, I hate when people say "fer" because F-E-R is not a word. 6.3 is our homework. If I don't have it live by AO, please remind me, but I'm going to try to make it live as soon as we go into second block, so hopefully it'll be there. So when we talk about percents at all, we want to use our percent equation. And when we see statements that involve the words is and of, is normally comes on top and of will normally come on bottom. And that means that those are the part and the whole of the situation. So let's say I order a 10-piece nuggets and I eat 7 of them. Did I eat all of them? No, so I ate part of the whole. Now if I order a 10-piece nuggets, can I eat 13 of them?
No.
Why?
Because you only ordered 10.
Hands, please. Reason.
That would be eating 130% of them, and you only ordered 100%.
So, who's ever heard a coach or a teacher or somebody say, give it 110%? If I could roll my eyes any harder, they'd roll out of my head when I hear people say that. What is wrong with saying, give 110%, give it 200%, give it 1,000%?
The max you can do is 100%.
Solomon,
The max you can do is 100%.
what do you mean? Why?
That's the way it is.
What is 100%?
100% is all you can do.
It's all of something, right? Now here's the question, though. I agree that the max you can do, the max you can give, like of your own effort, is 100%. But are there situations where we can use percents over 100, Jeremiah?
Dang it, I was going to say, but you could use things greater than, like, 1,000%, but that would be equal to 100%.
No.
Not necessarily.
If I give you 1,000% of the homework I was going to, that's not equal to the homework that I was going to. That's more. Honestly?
And so if you want to, like with your example, if you gave 200% of the homework, it would mean double the homework because 100% is all of it. So 200% would be 2 times all of it.
Yeah, so anything over 100% is more than the total. How, let's go back to our nuggets situation. How could I maybe get over 100%? Especially if you have a friend working there, maybe. Julian?
So, pretend you had the leftover 3 because you only ate 7 of the chicken nuggets. And then you buy 10 more. You would have 13.
No, you bought every time you buy, you're buying 100%. Dom?
If you have a friend working at how like you said, if you ordered 10 nuggets, they might give you 11, or you might get 12 nuggets, or maybe you might get a French fry in your bag.
If I get more than what I ordered, if I order 10 nuggets and my friend in the back hooks me up and I open my nuggets and I actually have 13, I have over 100% now, right? So although I can't give effort over 100%, I could have situations over 100%. If I invest $10 into the bank and I come back and I now have $11, I have over 100% of what I invested. So there are situations where we will use percentages over 100, but please do not use it in the situation of give it 200%. Those things are malarkey. So, we can use percents greater than 100 to describe quantities that are greater than the whole. If I was you, if you are a highlighter, I would highlight greater than the whole. So let's say we're doing a science fair experiment, and you will have the opportunity to do science fair in the 8th grade. Let's say we're studying bugs. We've got this bug population. So we've got 1, 2, 3, 4, 5, 6, 7, 8 here in the original population. This is year 1. We've got 8 bugs. Then, when I check back on my population, I now have 200% of year 1. Now let's break this apart mathematically. Now when I work with percents, we need to convert, because I can't actually multiply with the percent. And yes, some calculators have a percent button. I very much encourage you to avoid those. Learn the math, don't use the special button. How do I go from a 200% to a number that I'm allowed to multiply with? And Monica already told me. She said 200% is what?
200% is 2 times the whole.
So it's 2 times. How did I go from 200 to 2? Well, what are percents really? Like when we look at what a percent is, Ellie? We can make it a decimal, but a percent is like a reference to something. Elena? It's out of 100. So my 200% is really 200 out of 100, which is how I get to my 2. So when we see 200% of year 1 population, that actually means 2 times the year 1 population. Well, that was 8 bugs. I'm actually going to color code that. So my year 1 population is my 8 bugs. And that gives me how many? 16. So if I had 475% of the year 1 population, my 475% becomes what number that I can actually multiply with? Andrew? 400 point. Here's the easy trick. To convert from decimals to percents or percents to decimal, all we're actually doing is moving the decimal. So to turn it from a percent to a decimal, we move it 2 places left, and vice versa for percents or for decimals into percents. Yeah, 4 and 75 hundredths. Then the of, what does of tell me to do? Ooh, multiply. Per would tell me to divide. The year 1 population was 8. Do you know what it is?
No, but why do you move the decimal 2 times and not 3?
Because moving the decimal 2 times does the division by 100. If I did 475 divided by 100, because all percents are out of 100.
So, because 100 has 2 zeros?
Yeah, so if I did 475 divided by 100, division by a power of 10 just changes your place value. So my 1's place value becomes a decimal place value. My 10's place value becomes a decimal place value. It really just shifts my decimal 2 places over and lands it right there.
Okay.
So I get 4.75. The of tells me to multiply. The year 1 population, I plug in what I know, and what do I get? Andrew? 38. Can anyone verify that for me? Well, let's break this up. What would be 4 times my 8? Well, 8, 16, double it, 32. Then 0.75, well, that's really 3/4, right? So 3/4 of 8 gives me just 6 more, and I get 38. So I want you guys on these example problems to write the mathematical expression beneath it that we can actually solve using the decimal form, and I'm going to do one for you, and then find the answer and put the answer in the box. So if I was doing 200% of 1, 200% is really 2 times 1, and that gives me 2. So you want to write the mathematical statement. So 125% is 1.25 of, tells me to multiply, times 100, gives me 125. So go ahead and keep trying those. If you are confused or stuck, please stick up a hand. Plus, you know there's all the space between right here. You ask them if you can join up. Just if you want it to be easier rather than you having to lean over already. So make sure you're getting the mathematical statement written down under here. Make sure you're getting those written down. I'm going to use cards, so be ready. You have stuff written down? Because if your snack is affecting your learning, snack goes. Well, you have nothing written down since I stopped. this is when calculator use becomes more common. We will start using more calculators on your homework. If you want to use a calculator, you may. It is up to you. So Ashley, if I have 200% of 75, then what do I convert 200? Like, what does that become before I can multiply? Yeah, so it becomes 2 of, tells me multiply, 75. What was 2 times 75, Ashley? 150, exactly. What about 400% of 26, Acadia? What's the 400% become? 4 times, and what's 4 times 26? 104. Yeah, I'm using cards.
I have a question.
Okay, question.
I got the same answer for number 3, only I actually did like 200 times 75. Is that alright?
No, because it's not 200 times 75. If you did 200 times 75, you'd have gotten 15,000. That's not the right answer.
Decimal and move it over 2 and you get 150.00.
Yeah, but then you didn't explain your whole point. So did you do the multiplication and then divide by 100?
No, I just added the decimal.
You mean you shifted the decimal?
Yeah.
That's division by 100. You can't just move a decimal. Like, you are doing math when you move the decimal. If you move it left, you're dividing. If you move it right, you're multiplying. And it's always by powers of 10. Every space we move is a power of 10. So when you shift this decimal, that's dividing by 100. So that's fine as long as you divide by 100 at some point. Either you divide first to get the decimal value, or you divide once you get your answer. But either way, we have to do that division so we get it in the right form. Now that looks like a comma. 125% of 25. Monica.
1.25 times 25.
And what's that come out to be?
Oh, I forgot to do the math.
Ooh.
Okay.
So, at 25% extra, right? We have 100, which is the total. Excuse me, then another 25%. 25%, what is that as a fraction? Sam? A fourth. So just think of what's a fourth of 25. We'll split it in half once. You get 12 and a half. Split it in half again. You get 6.25. So you get 31.25. Since I have the whole 100% and an extra 25%. 300% of 2, Whitney. What's 300% become?
Just 3.
Yeah, 3 times my 2, and this becomes?
6.
Precisely. 1,000%, Solomon. If I'm doing 1,000% of something, what am I really multiplying it by? Like that 1,000% of homework? You don't want that, because that would really be how much times your homework, Solomon? So how do I go from a percent to a decimal? What are percents out of? If you had like 60%, that's 60 out of 100. So this 1,000 is really 1,000 out of 100. What's 1,000 divided by 100? 10, right? So this becomes 10 times 15. 1,000% is 10 times something. And it becomes 150.
Would that be minutes?
Yeah.
I didn't know that one, but I do know the next.
What's the next one?
7 times 5.
Yeah, exactly. Any questions on any of these?
That was easy.
So if we wanted to estimate 350% of something, what is that going to be between? That's between two kind of checkpoints we could think of. Honestly? 300 and 400. Because if it was 300%, it'd be 3 times. And 400% would be 4 times. So what would 3 times 20 be? 60. 4 times would be 80. So we know it's going to be right between there. I was actually doing this when I was tutoring this weekend. Think about how to make it easy. Right between 3 and 4, or right between 60 and 80, is 70. So greater than 20 but less than 50? No. Greater than 50 but less than 100? Yeah. because it's going to be 3.5 times. So, of all the things this year that I tell you you don't need to memorize, you just need to learn how to use it, you should memorize the percent equation. The percent equation has 3 manipulations, and this is the main one. So I would highlight, circle, star, something to get that off the paper and in your face to say this is important. But really, this all comes back to how we find a percent. How do I calculate a percent? Like if I got 35% of something or 47%, like how is that calculated?
Okay, like 35% of something would be 35 over 100.
That doesn't necessarily mean that I had 100 though.
Yeah, but 35 over 100 is equal to blank over, you need to find the number.
So what are these blanks you're talking about? How do I find a
Numbers that
percent?
you find. So like 35 over 100 is equal to blank over the number that you're trying to find the percentage of.
Well, what are these things called? Don't give me blank.
Numerator, denominator.
Yeah, but what are they when we're talking about a percent? We're going to use these words up here. Sam?
The part in a whole.
Part and whole. Percent, how we find a percent is just part divided by whole. If I know that I ate 2 of the 3 pizzas, well, first off, I'm probably going to have a tummy ache. But 2 out of 3, then I do the math, and then I convert to a percent. So when I use this equation, this is looking for the part. If I don't know the part, I use this equation. This is looking for the percent. I use this equation. So then we'll need to figure out, what if I'm looking for the whole? If I need to know what is my total amount, what is my out of amount? We're going to look at that. So a student says that 200% of 1 is 2. Another student says 200% of 1 is 200. Which one of them is right? And what error did the incorrect student make? Anyone recognize the error that they made, Dom?
The student said 2% of 1 is 2.
They are correct. What did student B do accidentally? Or not do, I guess. Anish? So student B forgot to convert. So we have to convert. So you could put right here, remember to convert. To decimal form. So, now one thing that I was always very interested in, if I wasn't a teacher, I'd maybe be out in the woods or the swamp or something doing research on animals. So let's say we have an animal researcher studying alligators. And we got to keep track of all these animals because, we live very closely to a lot of them. If we could just leave the animals where they want to be and not mess with them, that'd be good. But our population keeps kind of developing and we keep kind of taking over some land that they used to have. So let's say an alligator population is going to be 120% of last year's population. Now again, recognize this of always tells me that there's multiplication that's going to happen. So if we write down 120% of last year, well, what do I do to my 120%? Evie?
Make it 1.20.
I convert this to 1 and 20 hundredths or 1 and 2/10. The of, really mathematically, is going to tell me, Jeremiah, to multiply. And then last year, do I know last year's amount?
60.
Yeah, 60. Make it easy. Do I have more or less than 60? More. It's over 100. Any percent over 100 gives me more than what I started with. So I know that I have the 60. Don't reach for that calculator. Katia, see you. What would 2 times 60 be? Ellie? 120. But since this isn't 2, instead of being 120, it's actually 0.2. So I need to shift my decimal back in. It's only 12. So I had the 60 and I have 12 more. We'll have 72 gators this year. In that area. Yeah. So whatever their research area was. So, and have you ever seen these ocean spray commercials where they're out in the cranberry bog? That's real. Like, well, I don't know if that, like, where they are is real, but cranberries are picked. Anyone know how cranberries are picked? Acadia? Not with hands. How? How do the berries come off? Yeah, but how? It's a science thing I'm trying to get you guys to. What makes the berries come off the plant? The opposite. It is the force, but they float, right? So they are less dense. Yeah, they're buoyant. They're less dense than water. So literally, to pick cranberries, all they do is they pump a bunch of water in and the cranberries pick themselves. If they're ready to be picked, they pull off the vine. If they're not, they stay. So, during harvest, a cranberry bog is flooded to 4,800% of its normal depth. Because its normal depth is 1/4 of an inch. So normally there's this much water. So 4,800% is going to be a lot, but it's a lot times this much. So even a lot times this much isn't probably going to be that bad. So 48,000, again, somebody just said it, to convert it to a decimal, we divide it by the 100, and that becomes 48 times 1/4 of an inch. Well, 48 times 1/4. What's the same thing? If I don't want to think of this as multiplication, Jaslyn, do you know? Dom? Or Jeremiah?
48 divided by
Multiplication by a fraction is the same thing as division by the denominator, as long as there's a 1 on top. So if I multiplied straight through, I'd end up with 48 over 4, which is 12. So that bog is only a foot deep. So those commercials where those guys are standing in water like up to here, the bog they don't flood it that much because they don't need to. The cranberry plants aren't that tall. All they have to do is flood it to be taller than the plant. So it picks itself. Then what's really sweet, let's say they have a big bog like this. To collect them, they stick in a board. And then they attach another one to it. And they just keep pushing it all the way out until they've got these boards that are connected all the way around the bog. And then they just start pulling them in. Because the boards float, because wood floats. So they just make like a barricade all the way around, and then they just pull it towards them. And they have a big conveyor belt that goes up into the back of a truck. It's a very easy process. So it's really, really sweet. I watched a show on it. Yeah, it was the Dirty Jobs one. I like Micro. He's a good guy. So now wait. This question does not involve a percent. It's asking me for the percent. 96 is what percent of 12? Now if I go back to my first slide, I had a manipulation of the percent equation. Is of part whole. So what that slide is trying to show you is if we have a situation involving an is and an of, 96 is. It's the is. The of tells me how many are in the set. So I ate 7 of my 10 nuggets. I ate 3 slices of the 8. So I should set this up. Jeremiah? I don't want just an answer. I need to set this up. So I'm looking for percent. Yeah. Okay, how?
12 times 8 is 96. So if you multiply that by 100, you would get 800. And 12 times 800%. No.
You're kind of going a roundabout way to get there. What's the part and what's the whole? I want you to write down that percent is part over whole. The more you write it down, the easier it is to remember. Percent is part over whole. Here, and this throws a lot of people off. Andrew, what's my part?
96.
96. How many is my total? Or my whole? Yeah. I have more than the total. That's okay. Do not get confused that your part, quote unquote, is bigger than the whole. People get stuck that part has to be less than the whole. It does not. Part is just a placeholder for how many do you have. Out of how many should I have or how many do I need. And now I can do 96 divided by 12, which does give me 8. But to make this into a percent, I have to multiply by 100 actually to convert to percent. Guys, can you stop putting your feet up on there? I asked you last week, if you can't stop knocking that stuff off, quit standing back there. So this then becomes 800%.
I forget why you did the 100 thing.
Because to go to percent form, because what you have is 8 times the value. What we have is 8 times what we actually need. Because it's saying 96 is what percent of 12? If I asked you to go to the store and get me a dozen eggs, get me 12 eggs, and you come back with 96, did you get what I asked you to? You got more than that, right? So if I wanted to say, what percent did you bring me? You brought me 800%, because you brought me 8 times what I asked you for. Does that make sense? Alright, thank you guys very much. Have a wonderful day. We will finish up these notes tomorrow. No, I was teaching. I can't think about a riddle while I'm teaching.